if you can just go there, you'll have access to all of these tutorials. More chat. Yep. Yeah, it's going to be available on this page, the link that I've just sent. I'm going to take it off after a week, so you guys feel free to download it or whatever you want to do with it. So like we created a tower, which it didn't require any input on in Rhino. We're going to do a similar exercise and create a parametrically controlled surface, and it doesn't require any input from Rhino. So a crazy, like a clothy surface. What we'll try and create is a surface which is, you know, as crazy as that and flops around in any direction. There's all going to be a surface, and then we are going to figure how to panel it. Now this is where the paneling tool comes in. I hope everybody has installed paneling tools. Paneling tools is available for both Mac and Windows. So if you haven't installed a paneling tool, you won't be able to do this exercise. So I genuinely hope that you have installed paneling tools. The link I had sent during the workshop structure. So at least a majority of you have paneling tools. Please give me a yes.
Yes, sir.
Yes, sir.
Yes, sir.
Awesome. So you'll see a little tab that appears in the component bar. It's called paneling tools. But before that, before we head into paneling tool, let's make a base surface. So on Grasshopper, let's do a rectangle. Now, rectangle needs a plane, so we're just gonna give it a point. So point, right click, 1 point, say here. With this is how you'll set up anything, right? And let's give the rectangle a dimension. So 200 to the x, and 125, 135, whatever, to the y. So you have a rectangle. I'm going to work in perspective mode first. You have a rectangle. I'm just going to give boundary surfaces like we've done before. Boundary surfaces under surface, freeform boundary surfaces. It creates a surface. And then what I'm trying to create is, we will create a surface with these 4 endpoints, using these 4 endpoints, and maybe 1, maybe 2 middle points. So I need the endpoints. So how do I get the endpoints? I need the curve again, the boundary curve again. For a curve, usually there is, for a line, for example, there is a command called, I'll show it to you. There's a line. Oops. Suppose there's a line. Just follow me. You don't have to work on this script, but what on this part of the script. This is just to show you something. Set one curve. There is a command called endpoints, and it will pop up the 2 endpoints, start point and end point, if it's in a case of a curve. In the case of a closed curve, which comes onto itself, there cannot be such a thing, because the start point is the end point, right? So basically, we can't use this. We have to have edges, all the corners. So there's a command called discontinuity. What is discontinuity? Just I'll explain you. If you look at its icon, you'll be able to understand. But what's happening is, so what's happening is, if you have a curvature, an arc, at every point there will be a tangent. But the tangent makes a sudden jump if there is a kink. So that is the discontinuity. So if this is not a smooth arc, then there will be a discontinuity at this point. So basically to look for kinks in a curvature. So which is exactly what we want. We want kinks, and we want 4 kinks. So we have this called discontinuity. Okay. Simultaneously, what I'm going to do is, and then we need a point on the surface. How do we get a point on the surface? There's a command. This is a very important command. It will be used a lot of places. It's called evaluate surf. Okay. Please follow this extremely carefully, because I think somebody else yesterday also asked about the purpose of reparameterize as against remap. So I'm just going to cover 2-3 concepts rolled into one. First is, what is evaluate surface? Now, remember that little table that we discussed the basics of parametrics in our presentation? Difference between this and this. This is absolute value, and this is a parametric value. It's a dependency. So now I want to find a point on the surface. Say I want to find a point here. If I knew the length and the width of the surface, which I do know, 200 by 135, then I would divide it by a certain amount and I'll get that point, right? What if that constantly, that value keeps on changing? So that is where we need to link it parametrically. So we have this component called evaluate curve. I'm going to bring it like a number slider. There is another slider called the MD slider. It's called the multi-dimensional slider. And what it does is it actually shoots out 2 numbers at a time. So for a surface, you need this, because surface has both the values, right? It has the values coming from X direction and the values coming from Y direction. So that's why you need a multi-slider. A single slider won't work. And if you notice, evaluate surf is also looking at 2 inputs. So I plug in the multi-slider and I give it the surface it needs. So what's happening now? If I zoom in, it is doing something there. It is moving a point around, but it is moving the point around in the first grid, 0 to 1, 1 to 1, and that's it. That's where it do. Like the principle of remap, for geometry, there's a quick fix. You right click on the input and say reparameterize. Now this is revolving on the entire surface. Understood? Give me a quick yes.
Yes, sir.
Right, so someone asked me reparameterize yesterday. Is this better example? I don't know who it was.
Yes, sir, it was me.
All right, okay. So now we have the 5th point, and we have a corner points. We'll just use these 5 points to manipulate the surface. First of all, let's just turn this into a single list. Currently, this is one list and this is the other list. Let's turn it into a simple list. Let's call merge. Add this point here.
So can you change the icons to name?
Oh yeah, sorry. Merge. And then I'm going to flatten it. So all we've done is actually just taken the list, and put it into 1. So we don't need anything else. So far, we just need this guy and the surface. Okay. This is one method. This is one, though we got the points that we want to manipulate with. But like yesterday, with when we did the master plan, we need a set of points that need to be manipulated. So what we do is we divide the divide surface, and we divide the surface into, say, 20 divisions on both sides. Got this? So like divide curve, there is something called divide surf. And remember, what we needed to work for that master planning attraction script, we needed a distance. So same thing we need here. We need a distance. So I'm going to flatten these points again. We just need one list. Oh, sorry. Flatten 3. Okay. And this is, so we need a distance between these guys. The common distance, the closest distance for all of these. So there is something that we can use is pull point. As the name suggests, pull a point to a variety of geometry. So the geometry is this. The pull points are these. So let's visualize it. Stick with me for a bit. You'll once you see it, you'll know what's happening. So there we go. What's happening is that now all the points, which is 21 by 21, sorry, 20 by 20 points, they're finding the closest point amongst the 5 points, the 4 corner points and 1 center point. You see? All the points are just finding which is the closest attractor point to them. Yeah, got it?
No, could you explain the application behind this? Like, where can we use this in particular?
Yeah, that's what we're doing, man. Just 10 more minutes. You're going to see that application. What I'm trying to do, okay, let me explain this first. What I'm trying to do right now is, Prateek, you asked me that question, right?
Yes, sir.
What I'm trying to do is, Prateek, that I'm trying to change the profile of the surface based on these 5 points. Okay. However, to make a new surface, I'll need another grid of points, right?
Yes, sir.
So think of these 5 points as attractors for that potential surface. So I'm trying to repel or attract based on these 5 points, the other gazillion points that will potentially make a surface. It's the same what we did yesterday with the master plan. Principally, it's the same. Okay, application, we're just getting into it. Okay, this is done. So now our favorite component that we all love close to heart, the remap shows up again. Again, it's the whole variation of changing the different values to 0 and 1. So this is the value we want to change. its bounds. We should know this by heart now, and we want the value to remain from 0 to 1. I'm going to throw this into a graph mapper. Stick with me for a bit, you'll see what I'm doing. Just a second. We know all of these guys. Graph mapper we've already used. So panel. Just to give you an idea. All I want to do now is move all the points, the entire grid of 20 by 20 up Z somehow based on these 5 points. That's all I want to do. So I want to move all the points by unit Z the geometry is coming from here. So if you notice, everything has moved up, but I want to move it based on the distance of these attractor points. So simply, I can either take the graph mapper and put it there, but the difference is very minute. You're not able to see it. So I'll remap the entire thing again. Remap the entire thing again. For the values are here, and the source is already 0 to 1 since the target here was 0 to 1. And let's say the smallest height I want to extrude is 2.00, and the highest height I want to extrude is 31.00 meters. And voila. So what we've done through all of this exercise primarily is to manipulate a grid of points. So now you see what's happening. That attractor point changes your surface. It's like a cloth. Yeah? Got it? And you can also play with, of course, the Bezier. You've got a parametrically created surface. Currently, it's a web of points. So there's a simple command that's called surface from points. This one, surface free flow surface of points. And all you need is you need to plug this in. And it says a U count. U count is basically the number of divisions. It has to be the same that we used to create the surface with, plus an additional 1. Thanks. So I don't know whether you guys are with me or I've lost you somewhere. Is this clear? Principally, if not code-wise.
Yes, sir, but why can't we use closest point instead of pull?
So, so closest point what we used yesterday was for a curvature, right? For a curve closest point.
Sir, is there a closest point like for a point itself, like not instead of a curve?
It's called pull.
It's a pull.
It's just called pull. It's actually the same principle. It just does the same thing. It's just called pull.
Okay.
That's all.
Okay. Yeah.
You're absolutely right. It is the same thing as curve closest point, just that it's just called something else.
Okay. Okay.
Right? Okay. Here's a cute little trick. What's happening if I want to create another point that affects? So I can just copy this and I can make an evaluation change and add this point to D3. So now you have another dent. So you've got two dents affecting your surface. Got it? So, okay, now you want this surface. Imagine if nothing else, all you foresee is this is a 3D tile that you want to clad your wall with. So this will repeat there and there, and you'll have a dent in the middle. So can you just imagine that, this thing multiplying in both directions, right? Or whatever other purpose. This could be roof of your project. It could be a tile. It could be a bench, whatever your application is. Currently, depending on your scale, you're able to manipulate it. So this is the first exercise. Again, let's group it. Let's get it in good habit. Scribble, and let's call it base.
Could you repeat the surface grid part again, just the last part?
Do what? Sorry,
The-
what?
The surface grid part, the last part.
Ye wala?
Only the last. Yeah, this one.
Okay, so let's get rid of this. So we've got points, right? We want to make a surface out of it. Okay, there is this command that's in surface in front of freeform, which says surface from points. So just by name, it makes sense that we use this. So first thing it's saying, it's asking us is a grid of points. We've already got a grid of points. We'll feed it the grid of points. And then the other thing it says is give me the U count. Remember where we divided the surface, we gave it a U and a V count already. So these numbers are actually U's and the V's. So what we need to do is we need to give this number. Oops, sorry. We need to give this number there. However, it shows an error. Now what's happening? When we divide surface and give it a U and V, it's asking us for number of divisions. So the divisions, the gaps, this. Here, it is asking for the number itself. Then by default, that number is one more than the number of gaps, right? So if you have, 2 gaps, you have 3 points to make 2 gaps, right? So all you do is you go right click here, expression, x plus 1, and you have the surface. Guys, I would like you guys to follow through. I know you'll be getting the scripts in any case, but just understand the principles. It will be just more useful than just having the scripts.
Sir, can you give us a quick revision of it?
Yeah, sure. I'll give you a quick revision. Okay. So first thing, we made a rectangle of a certain size. The rectangle gave us a curvature only, but we needed a surface. So we made a surface by a command called boundary surfaces. Okay. Then we needed 4 points. Then we needed 4 edge points. We need 4 edge points. We wanted 1, 2, 3, 4. And for that, we used discontinuity. Discontinuity gave us 4 edge points. Next thing we needed was a point somewhere on the surface. For that, we used evaluate surface, and we use a multi-slider, which can adjust a point anywhere. Since you've seen the entire process, you know what we needed them for. We needed them to push and pull on the surface, the eventual surface that we were trying to create. This little exercise is like yesterday, it's manipulation of lists. We don't want, so currently these 4 points were where did it go? These 4 points were lying on one list, and this point was lying on one list. We wanted it to be on one, so we merged it and flattened it. So visually all of this will look the same, just that now they are on a single branch of a single list. So that bit of exercise was that. Now, to get the attractor points. Now the next exercise was that we can only make a new surface if we had a multiple of points. So we divided the original surface into multiple of points. This is the number of points. The number of points would be one larger than the number that you see here, because this is actually giving the number of divisions, 20 divisions. So like I said, if you want 2 divisions, you'll have to give 3 points, right? 1 division means 2 points. So the number of points is always 1 additional. So we divided the surface. We got the point, we need the points, but we need the points in one list. So we flatten it as a branch. Again, this is just knowledge from yesterday, basics of Rhino. Look at this, different branches, and this guy, all the data in one branch. Difference between 0, 0, 0 and just 0. Everything is in one branch. So we flatten it. Now we flattened the attractors, we flattened the points that we need to be attracted. Like curve closest point, there is a command called pull, which does the same thing. It finds which is the closest point to a grid of points. So that's what we need to do. It gives us a distance. And now we take this distance and convert this into height. That's all this exercise is. You can do it without the graph mapper, just that graph mapper gives us a better graphical control. So this whole exercise is the same thing we've been doing again and again. We take the distances and turn them into a remapped factor of height.
So my graph isn't showing the curve. My graph.
Right click, go to graph types. Right click, go to graph types.
Yeah.
And then have an option or to choose from many. We are working on something called Bezier.
Okay. Yeah. Got it, sir.
Got it? And then you can manipulate the middle nodes, right?
Yeah. Thank you.
Awesome. No problem. Okay.
In the surface grid, when you set the expression, what do you set it as?
Here?
Yeah, the expression of it.
X plus 1.
Okay, thank you.
I'm sorry, but can you explain why do we do the x plus 1?
Yeah, sure, no problem. Okay. I just hope that everything is not way above, it is at least hitting the forehead, right? That's there. And for those even this is well below what you expected, I apologize. This is a beginner's course, so I'm kind of torn between an intermediate and a beginner kind of scenario here. Okay, Jasnain, right? This is what you asked. Why do we need a plus 1? Okay.
Yes.
Just a second. I'll rely on my annotation skills. Okay, so you have a line, and you say that you want to divide the line into 3 segments. So you want to divide into 3 segments. Okay. How many points do you need to divide a line into 3 segments? You need 4 points. 1, 2, 3, 4.
Yeah.
To get segment 1, segment 2, and segment 3. Right? That's obvious. Okay.
Yeah.
What's happening here is that this surface grid requires number of points. Okay, so it requires that number of points to make a surface grid. While here we were giving number of divisions.
Yeah.
So points are always going to be 1 more than the number of divisions.
Yeah.
So that's all we did. We just went here and we just added in an expression x plus 1.
Okay. Got it.
Got it?
Yeah.
You know, we needn't have done this. We could have easily put 21 here. But now
As
it's
a
linked
slider, yeah.
parametrically. It's linked parametrically. If I change this, there won't be any error. It will keep on adapting.
Got it.
Got
Thank
it?
you. Yes.
Okay.
Sir, is there any possible way to form a surface with points other than surface grid?
Surface, let's see. Go to freeform. These are the ways you form a surface, man. Control points from loft, edge surfaces. These are the ways you form a surface. So the thing about, again, Grasshopper is that there are, say, 10 ways to do a certain thing. And all you have to do is you make sure that everything that precedes it gives the final component the inputs it requires. So to answer your question, these are the ways to form a surface. If you can find any of these, you'll be able to get a surface.
Okay, sir. Thank you.
Abhishek,
Haji.
the surface grid, you put in input the U value, but
U and V, yes, huh?
Yeah, but it may be possible that U and V are different. Then you may have to put two values, right?
Yes.
Okay, good. Yeah.
Yes. So there could be a scenario where this is actually this, right? And now if you look at the grid, it's very different. Yeah. Okay. All right, let's move ahead. Base surface done. Now just group it, align it, make it
Sir,
neat. Yes,
so
sir.
in that case of different U and V values, how can we form the surface grid?
Because this guy is asking for you. It doesn't want V.
Oh, okay, fine.
Yeah. So give it what it wants. Yes.
Yeah, sir. Okay.
Okay. Next thing, what I just want to do is a simple exercise, and this will probably help in a revision as well. That we want to copy this surface several times over. So I prepared 8 methodologies. So I just want the surface to be copied, 8 times on my Rhino. So that's just the next exercise, but it'll help you revise the square grid and the rectangle grids that we've been doing so far. So this will be quicker because we've done it before. Let's just use a command called relay. Relay is just, as the name suggests, it's just old information in a new package. So we need the base surface, which is this guy. Need the base surface. Oh, need the base surface. Okay, and we need to copy it. So I'm gonna say I'm gonna make a rectangular grid. Oh, sorry, not rectangular grid. Vectors, rectangular grid. We've done this before, and I will input the number dependent on the size of the grid. I'll make it dependent on the size of the surface. So I'll bring this number here, and I will bring this number here. And now my grid is exactly the surface dimension. Okay. I said we're going to make 8 surfaces. So this is a grid of 10 by 5. We just need like a 4 by 2. I'm just going to do 5 by 2, and I'll tell you why. So there's a grid. we want to copy the surface in 1, 2, 3, 4, 5, 6, 7, 8. We make 8 copies. But just graphically, what's annoying me is that if I copy a surface here, it'll start kissing the original surface. So I just need to increase the size of the grid ever so slightly. And that we can simply do by an expression or a multiplication. So multiplication of right click, set a data item to 1.5. I just wanted a cleaner copy. That's all. So I've just increased the grid size. It is still dependent on the dimension of the original surface, but it's 1.5 times bigger. That's all this little trick was. You can also do it with changing the expression x into 1.5. That also works. This is another methodology. Choose your devil. It's up to you. Now, how do we copy? we need the center point of this surface to get copied to center points of all of these. How do we get a center point of the cell? Again, area command, and we get the center points. We need this center point. How do we get this guy's center point? There's a you could just use the average, and I'll just use a new command. You can use an area like we've done here, but I'll just use something else. Remember these edge curves? These edge curves, I'm gonna take this edge curve forward. I'll create a relay here. And I'll just get this edge curve there. Okay. And there is a command called average. It's a beautiful command. It averages out any input. If it's a geometry, if it's a number, it averages out everything. So it's a very useful command. That's why I'm using it. It's a little heavy command. So if I give it a interesting, it didn't work. Just let me check what's going on. I need an average of points. What did I carry? Oh, sorry, I needed discontinuity, not curvature. Sorry, I needed discontinuity. I needed average of points, and there we go. We get an average of a point, right? Bang smack in the middle. So we need to move this surface from this original point to all of these target points. So line, 2 point, start point, end point, you got it, and we get into our move command. So what do we want to copy? We want to copy the surface to these guys. There we go. Okay, so all of this is now redundant. I don't want it. I don't want any of this. I don't want the area. Okay, but I don't want these two guys. I just want 8 surfaces. So I think somebody asked me during parametric tower, how do I remove 2 specific points from the entire list? And the answer to that is cull index. Cull index. So, and which indexes you don't need? Let's try it out. You 0 to one error I would have made. So we need to flatten this. So 0 to 0 to 9. So if you notice, It's fluctuating between which one I don't need, right? It's removing one by one. So I don't need this one, which is 0, and I'll make a copy, and I don't need 1. So those two are gone. We'll work with these copies. Is that clear? Simple. So this is just so we've just revised making a rectangular grid, making multiple copies, and culling a list. Culling a list based on this component called cull index. Index, again, like I said, is the address of each the item that got stored. We're good?
In mine, the rectangle and the surface is like next to each other, like how you have an offset. I don't have that.
Okay. What I did was in your just before when I made the rectangular grid, I did this little exercise where I multiplied the number that I'm getting from here by 1.5, and then I fed that into Sx and Sy. Could you do that? Did you do this little exercise? That's all. Just change, right click on B and put a set data item 1.5. You can also do this with a slider. You just say 1.5 and plug that into B. You choose your method.
Done. Thank you.
Awesome.
So can you show it again? The entire
So
thing.
what?
The
So
entire,
what?
the entire file.
Okay, this guy is your surface that we created prior. Okay, this guy is the edge points of the base surface. Edge points of the base surface. What I first did was, all we need to do is we need to copy this surface multiple times That's all we need to do. So what we did was we created this regular, like a rectangular array by a command called rectangular grid. Rectangular grid lets you give the X and the Y dimension of the grid. X and Y dimension of the grid, which is Sx and Sy. What we decided to do was that we tried to link this Sx and Sy with the dimension of the surface itself. You need not do it, but this is just a good practice of linking everything parametrically. So every maneuver is tied to a previous maneuver. You need not do it. You can just feed in whatever numbers you want here, right? But we chose to link the dimension of the surface, these numbers, into the rectangular grid. We could have done simply this and it would have formed like that. But I know for a fact that this would have annoyed us because they're all sticking to each other. That's why we just added like a 1.5 factor into the grid size, and now we have an offset, a distance, right? Okay. That was what this grid was. Then our next move was take the center of this surface and move it to the center of all of these surfaces. Then we just moved the surfaces to the centers. It's pretty much like copy with base point in AutoCAD. You figure a base point and just paste it at a certain place. That's all we wanted to do. So how we did that was we found the centers of the grid by this area command. You get the centers of the area command, and we use average to get the center of the base surface. And then, like how we've been doing several times, we just move it. Move requires the original geometry and the direction, the vector. Vector comes from joining that line to the target lines, again like copy with base point, and we get what we'll get multiple surfaces. You can work with these multiple surfaces. I'm just elaborating that if we want to not work with all surfaces, we just want to work with some of them, we can trim the list, or how it's called in Grasshopper, cull the list. Cull again is an English word to eliminate, to limit. We can cull the list, and this command is called cull index. Now, index means the address of every item in a list. So these guys are these guys are listed like that. They are 10 untrimmed surfaces. 10 untrimmed surfaces. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We want to get rid of 0 and 1. So we use cull and we put 0 in and 1 in, and then we get rid of them. So now we're going to work with these 8 surfaces. How's that? Okay.
So why do we have to make a line?
What line?
From the average battery and from the area.
We don't have to make a line. That was just to show you. So technically we don't have to make a line. So, what move needs is, hear me out, what move needs is, it needs a vector. It needs a direction, right?
Okay.
It needs a start point and an end point. It needs a T. The information that it needs, it can get if a line is made.
Okay, fine.
See, we are not viewing a line. We just need, it's an intermediary. It's a licensing agent. Line.
Okay, sir. So move battery doesn't work with the point.
It is Vinod, it is actually working with a point, no, but it needs 2 points. It needs a start point and an end point.
Oh, fine.
Right? It needs a start point and an end point, but concised format of a vector.
Okay.
Or like we've done before. Okay, let me try and explain this for larger consumption. Okay. You have this geometry, any geometry, and you want to move this point geometry to this point.
Okay.
Right? Now, one way is, you know the axis. So you know that it's on the Z axis. Right? And you know that it is 5 units on the Z axis. So you can simply say unit Z, and then you can put 5 into unit Z, because the move command needs a vector. Vector is a direction and a value. Right?
Okay.
Or the other way to do it is, you pick this point and then you choose the final point, like how we would do it in CAD.
Yeah.
Right? Those are the 2 methods.
Okay.
If I make a line from this point and that point, and I give that to the move command, it knows line has a start point and an end point.
Oh, fine.
That's why you feed it a line. But actually you're feeding it a start point and an end point.
Yeah, sir. Okay, got it. Sir, so some of them sent in messages like, what's the difference between a rectangular array and doing things like this?
None. You choose
Okay,
your,
fine.
this absolutely none. Sorry, I'm not reading the chats. Just a second, let me go through chats. Can you switch on bifocal? Can you share the script? I'm getting error. Can't we do an array instead of this exercise? Yes, to moving array or rectangle. Yeah, you can use any of these. So this is a rectangular grid, which is actually a rectangular array.
Okay.
You can do it by multi-copy. You can do it by rectangular array. You can do it by square grids. You can do it any methodology. But everywhere you'll need to do, you'll need to find a start point and an end point to copy.
Okay, sir. Thank you.
You're welcome. Okay. Shall I move ahead? Yes or a yes?
Yes.
That's
sir.
yes. Okay.
Yes.
Okay.
Yes.
So far we haven't even started with paneling tools. So now we step into paneling tools. Let's do a simple maneuver. Call your list item again. Feed this list into this list. And once you zoom in, you'll see these pluses appear next to the output I. Just click it 7 times. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Click 7 times because we have 8 surfaces. Now we have 8 outputs. And say SRF and join this and copy this SRF total of 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Okay, another neat trick of arranging in Grasshopper, just move the bottom guy out and then you can just distribute it. So you've got 8 surfaces. And now join each of these surfaces to each of these numbers. So you've got the first one in I, the second one in 1, third one in 2, and so on and so on. And anything before these surfaces, just select all and hide. You don't need. Okay. So the first surface, zoom into the first surface, which is this one, which is this one. For in paneling tools, under grids, how paneling tool works is on a simple principle that it needs a point grid to make to start playing with the geometry. So under grid tools, go to surface domain number, and this is the simplest way to work on paneling tools. Drop it in. Okay, and put the surface in, and let's say you put 12, set it to 9, set it to whatever you want to set it to. You change your grids. So you again have a grid of points. This is very similar to divide surf. This, however, is loyal to the, let's say, shape of the surface, and divide surface is loyal to length of the surface. So we're going to use this, called surface domain number. It's lying under grid, surface domain number, U and V here. And the simplest way to make panels now is go to panel 2D, generate faces. You feed it a grid. It needs a grid, it needs a panel shape, and it needs a surface. So the surface we give it from here, panel shape. If you hover over it, you'll see straight panel, pull panel, iso panel, a short panel. We just want a straight panel. And voila, you should get your panels. There we go. So now if you change your numbers, you get quad panels. So no matter how crazy, again, you can go back and change your surface. If you change your surface, it doesn't matter. Everything is adapting. So way back in like the first half of the first step, if you change the manipulation, you'll get an output that that you're probably looking for. I'm going to just add this guy to add complexity. There are two things that are controlling my surface. Disable it again. This guy controlling my surface. This guy controlling my surface. And end result is still quad panels. You with me? Okay.
What was the last component you used?
It's in panel 2D. It's called generate faces. I'll do it again. This is surface domain number. You get a surface domain number. You feed it a surface. You feed it a U value and an N value or V value. And then in panel 2D in paneling tools, you have generate faces. It needs a grid. You feed it a grid. It needs a surface. You feed it a surface. And then it says panel shape. 0 for straight, 1 for pull, 2 for iso, and 3 for short. We just need straight faces. And there we go. Right? Okay, let's do another one. So this is just to get a quad panel. Let's move on to the other surface, which is this surface. Same, I need a surface domain number, so I'm going to copy this. I need the same values every time. So what I'm just going to do is I'll move this sort of centrally here so it can reappear on every surface. So this is the new surface. It's the same distribution of points. Okay. Okay. The next thing we're going to do is we're going to introduce a concept of we're going to make a quad panel, but we're going to effect it with an attractor. So how do we get an attractor on a surface? We've done it already in this tutorial. We call it evaluate surf. Multi-dimensional slider. We've seen it before. Okay, extra points to anyone who figures or gives the right answer. This is still not, it's still not performing the way we want. What do we need to do?
Reparameterize.
I wish we weren't so bored though. Reparameterize, and there we go. Perfect. Right. So this becomes your attractor point. In your grid attractors under paneling tools, there is something called point attraction. You bring it down. Grid attractors, point attraction. What does it need? Grid. Give it a grid. What does it need? Attractor. Give it an attractor. And it's already getting manipulated. However, let's see. This is magnitude. Okay, so if I want to repel it, I'll probably go negative. So let's go -5 less than 0, 5. And this is the magnitude, and this is the repulsion level. I'm going to hide that. So you just see this. See how the grid gets repelled with the attractor or gets attracted. Right? Okay, and the last bit is the same thing we did here. We need PT faces. We don't need a surface. We need a grid, and we need a pull shape. So now if I look at this in the top view, what's happening is that you still have quad panels, but it can be repelled and pulled together depending on where your attractor is. So see that variation.
Why do you need the attractor, Abhishek?
Here or like in application or just in the script?
In application.
Suppose you want a larger window for a particular room.
Okay.
So this is your conference room, and these are your bedrooms, say.
Right.
Right. So. Okay, so we can do the same thing with now, instead of an attractor point, we can do this with an attractor curve. So you can, as you can imagine, the process is going to be quite similar. By the way, the principle that we've been using so far of using the distance, clear curve, closest point, pull curve, all of that still remains. Just the fact that what's happening with paneling tools or Lunchbox or Kangaroo or any of these custom plugins that come out, all of that information gets calculated in this. So while we spent that much time, so we could have started with this, but then we would have never understood the concepts behind what this point attractor does. Behind it, all the math of getting the distances, copying, finding the lines, remapping numbers, all of it is happening here by default in just this little component. Just that somebody has already done that effort for you. So these have become shortcuts. But when Grasshopper started out, or even coding started out, we used to use all those methodologies that we've been talking about for the last 2 days. It's made our life easier. And that's why you should definitely download several other things, Weaverword, Putterfish, paneling tools, of course, Lunchbox. These are all shortcuts to painstakingly long scripts to figure. So just to elaborate the amount of time we put to solve that oval for the parametric tower, imagine if you would just do it and give someone a plugin for it. That's what these tools are. All that information is not irrelevant. It's just background information. So same, now we want to do it with
Is there a way to get stuff if you have like a Mac?
Mac has paneling tools, it doesn't have Lunchbox.
No, yeah, I meant the other things like which we do not have.
It has Putterfish, it has Kangaroo, it has Ladybug. It doesn't have Lunchbox.
So is there an alternative for paneling tools?
Alternative? Weaverbird.
Okay.
But Weaverbird, I think, is paid now. I'm not sure. There are a lot of these tools. So in the last segment of the workshop, like I've shared, we will discuss what are the next steps and where you should go to download these plugins. So it's food for Rhino. It's called food numeric for Rhino. And you can you just register yourself and you can download the world. Most of it is free, but some of the real good stuff is of course paid. Lunchbox and Putterfish and panning tools is all free. Where was I? Okay. Let's do.
Sir, Could you explain again the point attraction battery?
Yeah, just follow me on the curve attractor and you'll know what happened in the point attractor as well. So I'll just teach both of these things together. Yeah, just a second. So what you do is you get your surface in a point, in a, what's this thing called? Surface domain number. What you'll do now is extract the iso curves of the, okay, this is this surface. Now moving on to this surface. What you'll do is now you attract the, you pull out the iso curves for the surface. Iso curve. What do we need for a UV? What do we need for a UV?
A domain.
No, we need, good answer. We need two numbers, but we don't, domain gives you a range. We just need two absolute numbers. How do we get a number?
MD slider.
Slider.
Slider. But we need two numbers. So what do we do?
Panel. Like write it in multi-line text.
MD slider.
MD slider. Multi-dimensional slider. So we do, we just copy this guy in, and again the same issue, it's just roaming in that area, so we need to reparameterize the surface. Now it's all over the place. You see these two iso curves. So iso curves are basically, say, hidden curves on a geometry. They could be profile curves. Technically, if you loft iso curves, you'll get the surface. So you have the iso curve, and now the simple thing is that you go to grid. Oh, sorry, grid attractors, and then you have a curve attraction. Pull it down. Grid attractors, curve attraction. Let's read it through. What does it need? Grid. We have a grid. What does it need? Attractor. So let's say U value. U value. And it needs a magnitude. So we'll copy this guy as before. Magnitude. So we've got the attraction going. If you see that, it's coming closer. It's going apart. So this line is being used as an attractor. We can toggle it by giving it the other line. So the other dimension gets attracted or repelled. And the last thing again is the same. It's the PT faces. So we'll just copy what we created on top. It needs a grid. And that should do it. And we just hide this. There we go. So same idea, this time getting attracted by a curve. So somebody asked me how we did the point. We did the same thing, man. We just evaluated the surface. We got a point out. Here we evaluated the surface with an iso curve. Sorry, we didn't use evaluate surf. We use iso curve. We get a point out in this scenario, and there is a component called, for point, it's called point attractor under grid attractors of paneling tools. Paneling tools, grid attractors, point attraction. For curve, we do panning tools, grid attractors, curve attractor. We put that in. It needs a grid, which we are creating with this guy. It needs a attractor, which we're creating here or here. And it needs a magnitude, which is, of course, as the name suggests, the strength of the attraction. And then we use the last component like we've been using throughout. It's called panel 2D faces. It's in under panel 2D, it's called generate faces. And again, we get a quad paneling based on attraction. Okay, I have 40 minutes. Okay, how are we doing on patience on 0 to 10? 5, 6, 0 being I'm dead, 10 being Yeah, come on. I haven't had enough. Give me more. Just throw some numbers at me. Five. Okay. What else? I'll increase the complexity based on how you're doing in terms of our understanding level right now. Shall I bump up, or you're good? Like, we can just take a couple of easy examples. So throw some numbers at me, please. Help me out here. Bump up. All right. Okay. Cool. 575. Okay. Okay. Let's bump up. All right, so we use the same. Now we've done with the quad panels. What we'll try and do is create some diamond panels, triangulations. Oh, sorry, diamond panels. For that, it's already a preset. Again, I just need I need your surface domain number. I give it a surface. I give it the U and the N value. I have a grid here. Now there is an easy trick again in Grasshopper. It's called under grid utility. It's called convert to diamond. So just notice what happens. You pull this down. This is this icon. Converted to diamond. Convert to diamond. Notice what happens to the points when I do that. It starts to pick up an alternate item in the list. Okay, so now your new grid is actually a diamond grid by default by just plugging in this simple number. And all you have to do now is go to panel 2D, generate faces, and the same information as we needed as before. And we have a diamond grid. Okay, so we've got 4 different kinds. We've got quad, attractor curve, attractor point, attractor curve, diamonds. Now, so far, this is something that we use is preset to panning tools. What's the exciting part about panning tools is if we can get to do actually custom panels. So in this bit below, we're gonna discuss custom panels. In these 4, we will discuss custom panels. Okay. So first thing for custom panels, it's let's try and get the first couple of steps are still the same. You get a surface domain number, surface, you get the same U and the same V in. We are working on this guy now. This one, green one. This working on this. Okay. You bring in a component that's called panel in panel 2D. It's called panel connections. Now, what does panel connections need? It needs a grid, which we all know what it is. Then it needs it's called a shift I and a shift J, and then it needs a pattern. If you notice in pattern, it's already got a pattern of 00011100. So what I'm going to do is, let's see if I put the provided a grid already. It's created triangulation. What has it done? Now, important point to know here is this I and a j. What is this ij business? Let's just see. If I take a param viewer to this surface grid we create, it says we have 18 branches with 13 values inside. Now, where is it coming from? It's coming from 12 and 17. So 18 branches, that means it's using this number 17, and with 13 values, that means it's using this number 12. So it's going from 0 to 17, hence 18 branches, and it's going from 0 to 12, that means 13 values inside. Right? Okay. If I just try and identify which is which, whether this is the branch or this is the branch. One way is, simply I know the 17 guy is the branch. So branches are running this way. This is the first branch. This is the second branch. This is the third branch, and whatever, this is the last branch, right? B1, B2, B3, etc., etc. Right? Okay. Just to check the same, what we'll do is we'll identify a branch by list item, the list, and we do a tree branch. Just understand the concept here. This is the grid, and this is the branch. So I know we just need to understand whether the branches are working in horizontal direction or vertical direction, because we should be able to know which one is I and which one is j. U, V, I, J, X, Y, it all means the same. It's just how a different component names them. So we're just trying to see which one is U, which one is V, because what's happening here is, now we've discovered that your I or your X is this and your Y or J is that. So how panning tools now understands is you're trying to, I and J is the size. So it's a default value is set to 1. That means your panel size is 1 by 1. 1 grid by 1 grid. So 1 grid in I direction and 1 grid in X direction, in Y direction. And your pattern now. Where's my annotate? Okay. This is I. This is J. What we are working with IJ is this panel size. 1 unit this way, 1 unit this way. What we need to give is a pattern in an IJ format, a pattern in an IJ format, I, comma, J. Okay. Now the coordinate geometry. This guy is 0, 0. This guy is 1, 0. This guy is 0, 1, and this guy is 1, 1. You with me on that? Yes. Yeses would help.
Yes.
Yes.
Awesome.
Yes.
Yes.
So if if I have, so all of these triangulations are working on start from 0, 0, go to, this will be 0, or sorry, 1, 1, go back to 1, 0, and come back to 0, 0. So that will give me a triangulation. Okay, so what we'll do here is, in your panel, I type 0, 0. Next was 1, 1. Next was 1, 0. And the last was 0, 0. Right click, multi-line data, you feed it into panel. Oh, it changed. So what yes, this is right, but what I just did, if you guys realize, is I've gone 0, 0, 1, 1.
It should have been 0, 1.
Yeah, so this is 1, 0, and back to 0, 0. But you get the principle. If I change this to, you're absolutely right. If I change this to the third guy to 0, 1, we'll get what we had before. There we go. And now what's happening with the I and j is, like we said, like I was trying to explain earlier, we've done this creation, and what we've told him is that our panel size is 1 by 1. So as soon as you're done with 1 by 1, just start repeating. Everything is 1 by 1, and in every 1 by 1, you have to go from 0, 0 to 1, 1 to 0, 1 to 0, 0. Does that make sense? Everything gets reduced to the same 4 points because we've defined the outer limit of 1 by 1. Okay, let's try and create the other closed panel, and I will take up similar examples so that it's clear to us. Okay, so I want to close this guy out. I don't want to leave it open. I want to close this guy out. So I'll just copy this 1 by 1 and only need to play with the pattern, and we solved it earlier. So we want 0, 0, 1, 1, that's fine, and this one will be 1, 0. So we need to flip this. And back to 0, 0. So 0, 0, 1, 1, 1, 0, 0, 0. And we get the triangulation going. I will just try. Okay, let's just shut this out and let's try it with where we change the panel size from 1 by 1 to 2 by 1. So same, we need in paneling tools, in panel 2D, we have panel connectors. Needs a grid, we give it a grid. Now, we don't want this to happen. I'm just gonna give it, I'm just gonna clear the values here. Okay. In the I direction, I want 2, and in the J direction, I want 1. Okay, let's try and create this thing now. Annotate. Let's try and create this, and let's try and create this. Okay, how do we do that? Let's create these two guys. So we know this is 0, 0. This is 1, 0. This is 2, 0. This is 0, 1. This is 1, 1. And this one is 2, 1. Okay, that's all we need to know. Let's copy these panels. Let's try the first one. First one is already there, I think. Yeah, first one gets formed because that's what we used last time. For the next one, what is our logic? We need 1, 1. We need x 2, 1. We need 2, 0. And we need 1, 1 again. There we go. So, and now what the logic of this panel size is that we've told the component that we are going to be working in a 2 by 1 panel. Once my panel is done, just repeat itself everywhere. That's it. So if I clear all drawings, scroll out, it's going to be everywhere. Is that understood? Yes. So the strength of for example, paneling tools is so that you can create your custom panels, to be honest. That's the exciting part. Okay, 4:40. Do we have time for one more? Maybe we do. Okay, let's see. Let's see. Sorry, my computer is frozen. Okay. Okay, let's try and create a truss. Okay, so for a truss, we need 2 grids. So far, we've been working with a single grid. Now we need 2 grids. I'm just going to use these 2 surfaces. So first of all, our base grid is the same thing that we've been using, domain number. And let's just create our new values, 9. What am I doing? Okay, then to create another grid, the simple thing we need to do for a space frame is how a space frame works is that you'll have center point, right? So your space frame has 4 edges, and then there is a center point which is moving away. So we need this center point. We need the center point for each of these. So it has a component It's called center grid. Center grid. I think it is here in grid utilities. Center grid. So you feed it a larger grid. It has a secondary grid. It needs a surface. There we go. So these are the center points of all of these points. And then we need something that's called coordinates. Coordinates is this. It needs. All we're trying to do is trying to move this guy up. We're going to move it up. So move it up with z. Coordinates. How do we move? Simple vector translation is move. Now, if I plug this in, it should be working. But we are unable to see it because the value is that small. Oh, sorry, geometry is sorry, this is the geometry. Yeah. See, you can see it. It's moved in by unit 1. But what if I want to control the amount of movement up or down? It's currently set. Oh, sorry, it's set at 10. So I don't want that high. Obviously, we know we can do it with the unit z, but here we are already getting a z vector. So that unit z that we always try and get, we're already getting it from here. Only thing we need is an amplitude, like a magnitude. So there is a command called amplitude, vector amplitude. So which is the vector? The unit z vector. And how much do we want? Say 2. Okay, so we can control this now. How far away we want our space frame to be. And this time what we're going to go into is a 3D panel tool, and this one is called this one is called 3D panel connections. So it needs the first grid, which is the base grid, which is this guy. It needs the secondary grid, which is this guy. Okay, Si and Sj same. We just want like this to be the component. So 1 and 1. Now let's come to the pattern. Let's come to the pattern. Now we have a third component. For the third component, what we're going to try is this panel. 0, 0, 0. Now we've got a third dimension. We go from 0, 1, 0. We go 0, 0, 1, and we go 0, 0, 0. Just see what happens. Let's just turn everything off and raise this guy further. See what's happening. So to make a truss, what we needed was, we don't need this as well. Oh, we need this guy. We don't need this guy. For the truss, we need to make, as we had discussed, 4 triangles, 4 planes. We need to make 1. We need to make 2, third, and the other one behind. We need to make 4 triangles to make a truss, a conical shape or space frame. So what have we done? We've gone from okay. We've gone from 0, 0, 0, which is this point, to 0, 1, 0. The third dimension is still nothing. The top guy is always a 0, 0, 1. Is always a 0, 0, 1. The top guy, and then you come back for all for every manipulation. It's always 0, 0, 1. That's it. Simple. The second grid's top guy is always going to be 0, 0, 1. Simple. So if you want to do this over and over again, we can just simply copy this. And what we need to do is now this triangulation would be 0, 0, 0, 0, 1, 0, 0. So we've gone from 0, 0, 0, we got 1, 0, 0, we got 0, 0, 1 and 0, 0, 0. So press shift, there we go, and we get this. I hope this is clear. And now we need to create these 2 segments. Same principle. Now we have 1, 0, 0 as a starting point, which is this guy. We need to go 1, 1, 0, 1, 1, 0, back to 0, 0, oh, sorry, not O, 0, 0, 1, which is the top guy, and starting point, which is 1. There we go. And similarly, exercise, we can just close it out by using the 4th one, which is this is 1, 1, 1, 1, 1, 0. This is 0, 1, 0. This and 1, 1, 0. This should close it. There we go. So here we get a space frame completely. I have to visualize, I kind of prefer a scenario where I can go negative, which is just easy for me to visualize. So I kind of always see a space frame like this, bottom members, and what we could simply do is instead of the surfaces, we can just extract a wireframe into a curve. Wireframe into a curve. I'm going to turn this off, and I'm going to turn off all the points. Turn off all the surfaces as well. You have a space frame, and simplest thing you could do is you can pipe. Pipe is a heavy command. Use it with caution. So let's say 0.2 is the radius. There we go. So we have a space frame. Okay. So yeah, that's it for. There is one more component which is interesting, which is to get a custom geometry onto our panel, onto our surface. I will probably, what I can do is I can share the script, you can play with it, and we can discuss it tomorrow, because it's soon going to be time for the lecture. I don't know whether Akshay has joined us. Akshay, if you've already joined us, give us a hello. Are you here, man? Hey.
Hey.
So it's been a while, sorry, since you joined?
Just came in.
Acha, okay, okay, cool. So yeah, let's just take couple of questions, and then we'll get Akshay under the spotlight. So any queries, guys? No? Cool. The most difficult part was the easiest to grasp, I guess. I hope it wasn't like all lost hope. Okay. I will share this script that we've made with you. I'll just make some edits and save it and send it back to you guys. So I'm not gonna save this one. I have something ready. I'll save it with you guys. Okay. Stop sharing. Hey man, Akshay.
Hi, how is the workshop progressing?
Ask these guys, man. I think it's going well. So I think there's just a variation in the learning curve, and that's why just to manage expectations is my little insecurity. But some of the questions that have been coming in have been pretty relevant. So
Right. Excellent.
right.
I like the background behind you.
Oh yeah, that's the office.
Uh-huh.
That's the office we did about a few years back.
Nice.
By the way, so we're live on Facebook. If there's any proprietary material you're sharing, I can just turn the live stream off.
Should be okay. I mean,
yeah.
If
your call. All right, guys. Do you want to take a quick 2-minute, 3-minute water break, bathroom break, and we can reconvene with Akshay at 5 p.m. while we chat. So let's just gather here in 5 minutes at 5 p.m. exactly India time. It's 4:55 now.
So please share the script.
I will. I'll just work on it, just clean it up, and I'll share it. Okay.